Good day friends. Today I shall be talking on the critical sets of Greco-Latin squares and Latin squares, GLS and LS, critical sets of GLS and LS. So to start with, what is a Latin square? A Latin square of order n is the arrangement of n square colors, n colors of each of n types in an n by n array such that in any row or in any column there is no duplicate, or in other words, in any row or in any column there are all the n colors. So that's called a Latin square. It has wide application in statistical design of experiments as well as scheduling problems. So I'm not going into this. I'm talking about the critical sets of these Latin squares and Greco-Latin squares. So I was in touch with Professor Rita Saha Rai from Indian Statistical Institute, who has got who sent me two papers on this critical set of Greco-Latin squares, and I extended this idea to the critical sets of Latin squares too. I haven't gone through the papers, but if anybody wants, I can provide them. So let's start with order 4. So let me create a critical set of a Latin square of order 4. I was working with colors, but here I am providing the numbers 0, 1, 2, 3. They're equivalent. Each color stands for each number, and there is no ordinal property of the number used in construction of Latin squares. I mean, they are just n objects. So I'm trying to construct the critical set of the Latin square of order 4. It's a trial and error method, and it takes time. How much you have to wait is a variable, nobody knows. Generally, within few trials, I get a critical set of so I got a critical set of order 4 Latin square. Now one can solve it. 2 goes here because 0 is here, 1 is here, 3 is here. So 2 is a unique choice for this cell. 0, 2, 3. So 1 is the unique choice. So I go by the unique choice and can solve the critical set of order 4 Latin square. Critical set means what is the minimum number of cells you need to cover so that the rest gets fixed uniquely. So that's a critical set of order 4 Latin square. Let me try critical set of order 4 Greco-Latin square. So that comes with 2-digit numbers. The first digits form a Latin square. The second digits form a Latin square, and all the pairs are available. There is no duplicate in any row or in any column in first digit and second digit, and also there is a duplicate in the double digit number. So I have got a critical set of order 4 Greco-Latin square. I can solve it. Critical set means you need to have the minimum set so that rest is defined uniquely. So that's a critical set of order 4 Greco-Latin square. Here I have the numbers. I have been doing this for quite some time now. For the orders 1 to 10, for Latin square, critical set size is 1. For order 2, critical set size is 1. Then 2, 4, 8, 12, 20, 28, 40, 49. Till now, for order 10 Latin square, I could get a set of 49 colors so that the rest gets solved uniquely, but I don't know whether 49 is the minimum. So that is still yet unknown. So these are Latin squares, and for Greco-Latin square we don't have any critical set for size 2 and 6 because Greco-Latin square of order 2 and order 6 do not exist. For the rest, the numbers I got are 1, 3, 4, 6, 18 for 7, order 7, 28 for order 8, 37 for order 9, and 46 for order 10. So these are the numbers that I have got till now, but probably this could be improved. And I have the support of each of the numbers. So these are the critical sets of Latin square of order starting from 3 to 10, and these are the critical sets of Latin squares of order starting from 3 up to 10. So I have the proof, I have the support behind my numbers. And here I play a game. Suppose I try the Greco-Latin square, which I am doing it by colors completely. And let me see if I can quickly get a Greco-Latin square of order 4, the critical set. So I have to do it by trial and error method. I mean, I don't have any algorithm to prepare these critical sets. So I do it by trial and error method. For order 4, it is doable. For other orders, which is possible, it takes time. It's very difficult to get a critical set of order 5 Greco-Latin square. It's taking time. These could be thought as puzzles. I mean, if you can provide a critical set, you can ask your students or friends to complete the rest. That could be done logically by going through the unique choice. Search out the cell where the color is fixed and then put the color. I've been doing it for 19 trials, and yet I'm yet to get a critical set of order 4 Greco-Latin square. No, I'll abandon it. Okay, I'll go up to 25, 21. Usually within 18 trials, one gets a critical set. 22, 23, 24. No, I'll go to Latin square. That's a bit easy, but yet nobody knows how long. So that's a critical set of order 4 Latin square. And so this is the set: blue, green, red, yellow, 4 colors. There are 16 cells, so there will be 4 red, 4 yellow, 4 blue, 4 green, and I just copy it to my palette, and that goes to my daily status in my mobile. My contacts get it. Every day I publish a critical set of order 4 Latin square and ask the people to solve it. So this is the sample of 2 order 5 critical sets of Greco-Latin squares, and these are 6 order 6 critical sets of Greco-Latin squares. I'll stop here. Thank you.